Hey, algebra students, in this lesson, we are going to be taking a look at how to use stem and leaf plots, but more importantly, how to use histograms. Now, here's what you need to know about a histogram. A stem and leaf plot really is a histogram turned on its side. What a histogram does is it makes a bar graph, but instead of having two different axes on your bar graph, most of the bar graphs that you had an x-axis where you had a certain number of numbers going across the bottom and a y-axis that had values going up the y-axis. Instead of having a y-axis like that, the y-axis is the count of the number of times a number appears. Here's an example of a histogram. So maybe I'm measuring the heights of students in my algebra class, or maybe in all of my classes, just so I have enough students. And what I might do is I might start my histogram at 4 feet to 4 foot 6 inches and count how many students are between 4 foot and 4 foot 6. The next between 4 foot 6 and 5, between 5 and 5 foot 6, between 5 foot 6 and 6. Then I would count up the number of students in each group. How many students are 4 to 4 foot 6? 4 foot 6 to 5 feet, 5 feet to 5 6, 5 6 to 6 feet, and then 6 feet to 6 6, and that's probably as far as I have to go. And then I would graph the counts of students for each of those different groups. What we find is that there's a maximum amount somewhere in the middle, and then probably smaller amounts at the extremes on either end. All right, let's practice looking at a few histograms, making a histogram as we do our lesson practice for today. Now, we're going to be doing both stem and leaf plots, which are sideways histograms and actual histograms in this lesson. We're going to start with the stem and leaf plot. The list shows the low temperatures in degrees for New Orleans for the first 15 days of April in 2007. Create a stem and leaf plot of the data. Okay, now I just want to point out that down below, we have a stem and leaf plot of the low temperatures in of the last 15 days of April, okay? This is the low temperature of the first 15 days of April. Don't get confused between these two graphs that we're going to be making. First 15 days, last 15 days. All right, so what is this stem and leaf plot going to look like? Well, first of all, I need to decide what's going to go on the left side axis of my stem and leaf plot. And what that's always going to be is the digits that show up first in these two-digit numbers. So in these two-digit numbers, what are my possible first digits? 4, 5, 6, 7. So I need to make sure that I have stems for 4, 5, 6, and 7. Then I'm going to have leaves for each one as well. For my 4s, I have 2 and 3, 42 and 43. I don't see any other 4s in here. Normally, if I were making this, I would cross off 42 and 43 when I put them on my stem and leaf plot just to show that they're done. But I should see a 2 and a 3. What this means, according to my key at the bottom here, is that I have my first digit here, and these are a count of how many second digits, 42, 43. All right, so I have two numbers that are in the 40 range. What about in the 50 range? What numbers do I have here? I see 52. Oh, 51. I have one lower. So 51, 52. 52 shows up twice, so I need to make sure I put that in twice. I have 54 and 56. I notice that I also have a 50, exactly 50. I'm going to put all of those numbers over here on my stem and leaf plot. Notice 0, 1, 2 gets listed twice, 4, and 6, because those are all my 50s. I would look through the list, find out which number is the lowest, cross it off, and then keep going. Hey, one of the things that helps in making stem and leaf plots, it's really helpful to start by putting your list in order from least to greatest, because then you won't miss anything for sure. All right, in the 60s range, how many numbers are in the 60s range? I see 61. Oh, here's an actual 60. I have two 60s, a 61, a 65, and a 69, and that looks like everything. So I'm going to make sure all those numbers make it onto my list. I missed one. Did I miss a 60, 260, 61, 63, 65, 69? I'm not sure that I said all of those. hey, that's even more reason to make sure that as you do this, you cross off the numbers as you list them to make sure you don't miss any. And then in the 70s, I have 70. That's it. So I'm just going to list that 170 value. Now notice what happened with my stem and leaf plot. I have fewer values at the extremes and most of my values are in the middle. That's what you oftentimes see with these. Now we need to create a histogram of the data. And the way I'm going to create a histogram is by making an actual bar graph, okay? And my bar graph is going to look like this. I'm going to, let's see, we're going to put a count of the number of days that show at certain temperatures. What are the temperatures that I'm going to use? I'm going to put 40, 50, 60, and 70, okay? And what this means is any numbers between 40 and 50 are going to go in my first bar. 50 and 60 go in my second bar. 60 and 70 go in my third bar, and 70 on up in my fourth bar. If a number falls directly on one of these, it'll show up in that bar. So if the number 50 would show up on the 50 bar, not on the 40 bar, because it's everything between 40 up to 50. So 40 through 49, really. All right, so let's do that. And then let's see. I need to have a vertical axis, but my vertical axis is always going to be the count. And I see that I'm going to have a maximum of 6. So we're going to go 6, 5, 4, 3, 2, 1. You'll see how this works out in just a second. How do I know I have 6? Well, I'm just going to count one of my rows on my stem and leaf plot. 1, 2, 3, 4, 5, 6. I have 6 5s. So I'm going to make sure that 50 gets a graph at 6 units tall. All right. And then let's see. What I really should do that I'm not going to do because it would take too much time on this graph, but I should have minor lines going across. So this looks more like a bar graph. And then this line is the one line. Okay. Maybe I will do this. So this line is the one line. I wish it was perfectly level. Not able to do that perfectly on here. This line would be the 2 line. Let's see. We'll put in the 3 and 4 lines here. Okay, and then the 5 and 6 lines. Now this is a little bit messy. If I did this on actual graph paper, this would look a little bit neater because everything would line up perfectly. All right, and then we need to make our bars. So the question is, how many 40 range numbers do I have? Well, 1, 2. If I look at my stem and leaf plot, there's 2 in the 40 range. So I need to make a bar that counts 2 high. So we'll do that. We'll start here and we'll go up 2. Now, in a true stem and leaf plot, your bar is going to be the width of the entire, in a true histogram, your bar is going to be the width of the entire region, and the next bar is exactly right next to it, okay? Now, in the 50 range, I go from, let's see, how many did I have in the 50 range? All the way up to 6. So this bar is going to go all the way up to the 6 line. In the 60 range, again, I went all the way up to, shrink that down a little bit, all the way up to 6. So it's going to go the same height as the other one. And then finally, in the 70 range, I only had 1. So my bar is only going to be 1 unit high. I have to shrink this all the way down to 1 unit. There we go. Move it over a little bit so it's right next to and not on top of. All right, that is the histogram. Now, I need to label my axes on every histogram I make. I can't just leave them looking like this. So on the bottom here, we have degrees Fahrenheit for the temperatures in April, okay? And then here's the important thing. This is true of all histograms. Of all histograms, over on the left axis is the count. It's the count of the number of days that fit the range of values, okay? And that's going to be true for all histograms. The y-axis is always going to be a count. How many days were there? 1, 2. This is different because, like, for instance, a graph of this data might have the dates along the bottom and then bars that reach up to the temperature. So my temperature would be on my y-axis. And then I'd be able to see, like, what the different dates in April looked like and how their temperatures compared. This is just giving me an overall count, so I could say, yeah, in April, most of the temperatures were between like 50 and 60. Went up down to 40s, up to 70s, but mostly 50 and 60. So if I'm going to buy like something to wear in April, I might buy a light jacket, not a heavy winter coat. And I'm definitely going to have a jacket because it's not up around 70 very often. Okay, so that's what our histogram would look like. Now, letter C, use the stem and leaf plot here. This is for the last 15 days to find the median, mode, and range of the low temperatures for the last 50 days of April. Well, okay, this is pretty easy because this is already in numerical or in least to greatest order. So I'm going to just count how many data points do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That means that 15 divided by 2 is 7.5. That means that if I get to my 8th data point, that's the middle one, there's going to be 7 above it and 7 below it. That is going to be my median. 1, 2, 3, 4, 5, 6, 7, 8. 60 is the median. Let's make sure I got that median right. Hold on one second. Median 60. Okay, well, I got all the other data here. The median is 60. The mode is going to be the data point that appears the most often, but you'll see because I revealed the secret answer a little early here. There's going to be more than one mode. Let's see. 45 appears once. 54 appears once. 56 once. Do I have any repeat numbers? 59 appears twice, but so does 63, 64, and 68. I have nothing that appears 3 times. Therefore, anything that appears twice is a mode. The modes are 59, 63, 64, 68. Anytime you have more than one mode, it's probably not a great measure of center because it's more than one number. And then the range, how do we find the range here? Well, I'm going to show my work. It's always a good idea to show your work. We need to take the biggest number and subtract the smallest number. We just take the number that's farthest down and right on our stem and leaf plot and subtract the number that's farthest up and left. So 71 minus 45, that gives me the number 26. 26 degrees is the range for this set of data. Letter D. Use this stem and leaf plot to find the relative frequency of 64. Remember relative frequency? It's the number of times a number appears compared to the total number of data points that you have. All right. So how many number 64s do we have in this data set? We count up the number of 64s. There's 2 of them, divided by the total number of data points. Well, I remember that number was 15, right? Let me just double check once again. This is 6 plus 7 is 13, 14, 15. 2 over 15 is the relative frequency. If we wanted to put that in a percentage, because oftentimes relative frequency is a percentage, it's 13.3%. So 13% of my data values are 64s, okay, because it appears twice, or 2/15 of them are 64s. All right, and then lastly, we need to create a histogram of the data in problem E. It tells us to use a graphing calculator, but we really don't have to. You could make a histogram without a graphing calculator. All right, so here's what our histogram is going to look like for the first 15 days of April. On the left-hand side, I'm going to have, it's going to be the number of counts. And what number am I going to go up to? Well, in the 60s, I have 1, 2, 3, 4, 5, 6, 7 different count, okay? So I'm going to go something that'll get me up to 7. Now, this is a little squished over here, but you can see it goes 2, 4, 6, 8, 10. 7 is somewhere on this graph. And then along the bottom, I'm going to need to have my actual values for along the bottom. I have 4, 5, 6, 7. So I'm going to make sure that 40, 50, 60, and 70 appear along the bottom. Okay. And then the last thing that I'm going to do is I'm going to actually make the histogram. I have 1 between 40 and 50, 6 between 50 and 60, 7 between 60 and 70, and then 1 between 70 and 80. And that's what my histogram looks like. All right, you are now expert histogrammers. You should be able to do the assignment for this lesson.